All right, so not all limiting reagent problems are as simple as working with cheese sandwiches. In this example, I have a balanced chemical equation. 2 moles of copper plus 1 mole of sulfur yields 1 mole of copper 1 sulfide. And I'm being asked to find the maximum mass of copper 1 sulfide when 80.0 grams of copper reacts with 25.0 grams of sulfur. I'm going to identify my limiting reagent, my excess reagent, and also the amount of excess. So in order to do that, I have to start by looking at my givens. The first step whenever you do anything is to write down the given information. In this case, there are 2 pieces of information that I'm going to be writing and 2 calculations that I need to perform. I find it easiest to figure out which of these particular reactants is my limiting reactant by just figuring out how much copper 1 sulfide each of them is able to make. Just like in my cheese sandwich example, I figured out how many sandwiches each of my reactants, my bread and my cheese, was able to make. So right now I'm just writing out my givens, and that's the first step you're going to want to do as well. Okay, so I have 80 grams of copper, 25 grams of sulfur, and I'm going to be solving for the amount of copper 1 sulfide each of these is able to make. Okay, now this is the chart that we've been using in class that kind of helps us take some steps out of our stoichiometry. Instead of having to go through our molar conversions, we've already accounted for the number of moles of each of these by taking it into account with the masses. So this is actually twice the mass of copper, and it's rounded off to whole numbers since that's how we've been doing it in class. All right, so the first step is to, like I said, convert, and we want to get our units into grams of copper 1 sulfide because that's what we're asked to find in our question. So here I'm going to have grams Cu2S, because again I'm going to put whatever it is I'm looking for up here. That's what I'm solving for. Now in order to solve for this value, I also have to be able to cancel this unit. I don't want to solve for copper. That's not going to help me. I need to solve for this. So I'm going to put grams of copper down here. I've got my units set up now, just like we've been doing in class. We're going to plug in our numbers that we pull from the chart that we've already calculated. So grams of copper 1 sulfide, we have 160, and that's just the molar mass. Grams of copper, we have 128, and that's twice the molar mass. That just saves us the step of having to go through the conversion of 2 coppers to every 1 copper 1 sulfide. And now we just put this in the calculator, multiply 80.0 times 160, take that product and divide by 128, and it gives us 100 grams of Cu2S. Okay, now that's not given in correct significant figures, but we'll worry about that in a minute. All right, so let's look at this one now. 25.0 grams of sulfur. Again, I want to solve for the product because that's what I'm being asked to find, the maximum mass of Cu2S. So I want to find the mass of Cu2S, which again, I can do by putting my units up here. That's what I'm solving for. And again, I pull my number here. The mass of 1 mole of that substance is 160 grams. And I have to cancel my other unit, my grams of sulfur, because right now I'm not set up to solve for anything except for grams of sulfur times grams of copper 1 sulfide. So I have to cancel these by putting it down here on the bottom. I didn't cancel those. Okay, grams of sulfur, and I pull my number again from my chart, and these are already the masses that I've looked up on the periodic table and just rounded off to whole numbers. We solve it the same way as the first calculation. You multiply the 2 numbers on top, divide by the 1 on bottom. Keep in mind that this setup is how we've been writing it in class, but this is actually essentially you're multiplying 2 fractions. Okay, same thing. All right, so 25 times 160 divided by 32 gives us 125 grams Cu2S. Okay, so just like we did with our cheese sandwich example, we're going to look at the 2 amounts of the product that we have. If we have 80 grams of copper, we are able to make 100 grams of Cu2S, copper 1 sulfide. If we have 25 grams of sulfur, we're able to make 125 grams of Cu2S. So we need to identify our limiting reagent and our excess reagent. So I'll just start up here. 100 grams Cu2S. Okay, that's how much that is enough. We have enough copper to make this amount. Do we have enough sulfur to make this amount? Well, let's look. Sulfur is able to make us this much. So if we can make 125 grams with the amount of sulfur we have, then we can obviously make 100 grams with the amount of sulfur we have. Okay, if I look at this value, I have enough sulfur to make this. However, I do not have enough copper. I have run out of copper. As soon as I make 100 grams of copper 1 sulfide, I no longer have any more copper, making this amount impossible for me to make. So this right here is the maximum amount. That's my maximum product. Okay, and that's what the question asked me for at first, maximum mass. So I've got that. This is the maximum mass, 100 grams. And the limiting reagent, the reactant, again, remember your reactants are here and here. One of those is my limiting reagent. The reactant that limited me to only making this amount was my copper, because I ran out of copper as soon as I met this number, 100 grams, and was not able to make the extra 25 grams that this was able to make. So copper is my limiting reagent. Okay. That also means that my excess reagent is sulfur. It's going to be the opposite of the limiting reagent, the other reactant, the one that I had extra of. And I'm erasing this so I have some room to write again. All right, so I've got my excess reagent as sulfur, my limiting reagent is copper. And my maximum product is 100 grams of Cu2S. Now the other question that I'm asked is the amount of excess. I need to figure out how much of my excess reagent, my sulfur, how much of this am I going to have left? So what I'm looking for now is I'm solving for the amount in grams of sulfur that I have left after a reaction with 80 grams of copper. Okay, I have to start with my 80 grams of copper because I know that this is the amount of copper it takes to produce this. So I'm going to start my calculation with what I already know. I have 80 grams of copper. And I got that value again from my question. And I'm trying to figure out the amount of excess, which is the amount of sulfur. So I want to find grams of sulfur. I have to be able to cancel grams of copper. I set it up the same way we've been doing that in class. I pulled the numbers from my grams from my chart up here, which is again just based on the periodic table masses. Okay, copper was 128 grams, and that's because it's 2 moles of copper. Sulfur is 32 grams, and that's just the molar mass of sulfur. And I'm going to take my 80 grams, multiply it by 32, divide by 128. This is going to tell me how much sulfur it took to react with 80 grams of copper. So whenever I solve this, I find that 20 grams of sulfur was used up in this reaction with 80 grams of copper. And if I'm writing it with correct significant digits, which I should be, and I'm going to say 20.0. All right, so this is the amount of sulfur that got used in order to make this amount of copper 1 sulfide. But that's not what the question asked. The question asks me how much is left. So I used up 20 grams. What did I start with? Well, we have to look back up at our question. A maximum mass of Cu2S when 80 grams of copper reacts with 25 grams of sulfur. That's what I started with. So I started with 25.0 grams of sulfur. I just used 20 grams of sulfur, which means the remaining amount that I have is 5.0 grams of sulfur. This is the amount of my excess reagent. So now I've identified everything the questions asked me for. My maximum mass, which again I should probably write with correct significant digits. 100 only has 1 sig fig, so if I'm going to write this correctly, I need to write it in scientific notation. And because if I'm writing in scientific notation, I have to put my decimal here. I just made this number smaller. I'm going to need to make my exponent larger. So it's going to be times 10 to the second, because that's how many places I'll have to move it to get it back to 100 grams Cu2S. So this is actually what I would write for my value for maximum mass of Cu2S. I have my limiting reagent is my copper, my excess reagent is my sulfur, and the amount of excess is 5.0 grams of sulfur. That's how you answer one of these questions on calculating your limiting and excess reagents.